Okay, now we're going to look at radical and complex number arithmetic, the very last lesson of our entire course, okay? And you will find that there's a lot of stuff in this that is fairly easy because it's like adding like terms and subtracting like terms and multiplying polynomials. So they're the same kinds of principles, but applied to another set of numbers, okay? So let's look at this. So when we start talking about adding and subtracting radical numbers, what happens? To be like terms, the radical has to be the same and the number inside the radical has to be the same. So this has to be the same as this. If these are not the same, they are not like terms and you cannot combine them, okay? So that's an important thing to know when we're doing adding and subtracting. Okay, so let's look at this. So if we look at this, these are like terms. We can combine them by adding the whole numbers, making 7 radical 3's, because what we've got is 4 of these radical 3's plus 3 more of these radical 3's, making 7 radical 3, okay? Such as, how about this one, radical 5 plus 5, let's make that 9 radical 5. Again, radical 5 and radical 5 are like terms. This is a 1, which we didn't write, so 1 plus 9 is 10 square root of 5. Like terms can be combined. So let's look at some real examples of this. 4 square root of 3 plus 2 square root of 3 is equal to 4 plus 2 is 6 square root of 3. How about this one? 9 square root of 2 minus 3 square root of 2. Square root of 2 is the same as square root of 2. These are like terms, so 9 minus 3 is 6 square roots of 2. Let's look one a little bit more complex. 8 square root of 5 minus 3 square root of 5 plus 4 square root of 5. So our first step is let's check and make sure they're like terms. Square root of 5, square root of 5, and square root of 5. So they are like terms. 8 minus 3 is 5 square root of 5 plus 4 square root of 5. 5 plus 4 is 9 square root of 5. As you see, it's just simply adding like terms. So what happens if they are not the same? Well, the first thing you're going to do is simplify them and then see if they are the same after you simplify them. So let's look at an example. Square root 36 minus square root of 100. As you see, these are not the same, but what happens when we simplify them? The square root of 36 is 6 minus the square root of 100 is 10. 6 minus 4, these are whole numbers. We can simply subtract and get a negative 4. So now let's look at one more complex. 6 times the square root of 18 minus the square root of 32 and plus 2 times the square root of 50. As you see, we're going to make you use all your simplifying skills on this. 18, 32, and 50 are not like terms. But let's simplify and see what they do come out. 18 is 9 times 2. Square root of 9 is 3. So 6 times 3 times the square root of 2. which is 18 square root of 2. This one is 16 times 2 minus square root of 16 is 4 times the square root of 2. So this is minus 4 square root of 2 plus 2 times 25 times 2 is your 50. Square root of 25 is 5 times the square root of 2. And 2 times 5 is 10 square root of 2. Notice when you have simplified them, everything now has a square root of 2. So all we have to do is look at our coefficients in front. 18 minus 4 is 14 square root of 2 plus 10 square root of 2 is going to equal 24 square root of 2. Okay. Now let's look at an example that has both numbers and variables. So I have 3 times my square root of 72m squared minus 5 times 32m squared and minus 3 times square root of 18m squared. Okay. Again, using all your simplification skills. M squared is going to come out as an M. So we have 3 times and then an M. So that one's gone. 72 breaks up into 36 times 2. Square root of 36 is 6 and leaves me a square root of 2 still in the house. So this is 18m square root of 2 minus 5 times 16 times 2 is 32, and an m is going to come out, leaving a square root of 2, and the square root of 16 is 4. Negative 5 times 4 is minus 20m square root of 2. Minus 3 times m is going to come out, and 18 is 9 times 2, so leaving 2 inside, square root of minus 3. So this is minus 9m square root of 2. Notice, every one of them has m square root of 2. They have to have that to be able to be combined. So 18 minus 20 is 2m square root of 2 minus 9m square root of 2. 2, that's a negative. Negative 2 minus 9 is a negative 11m square root of 2. Okay, now we're going to look at multiplication of these radicals. Okay? So, if I have a square root of a times the square root of b, this is equal to the square root of a times b. So, when we multiply these, what is inside the house multiplies together, and if we have numbers outside, the numbers outside multiply together. So let's look at this. How about square root of 6 times 3 plus square root of 2? So square root of 6 times 3, I don't have anything inside the house, so this simply becomes 3 square root of 6. Square root of 6 times square root of 2, you multiply 6 times 2 because they're both inside, and you get the square root of 12. This can be simplified to 4 times 3. Square root of 4 is 2. Square root of 3 is just 3. And then 3 square root of 6. And notice, even with simplification, that does not have like terms. Therefore, it cannot be simplified anymore. Okay, let's look at another one. square root of 2 times square root of 18 minus square root of 3. Again, everything is inside the house, so 2 times 18 is square root of 36. 2 times 3 is square root of 6. Square root of 36 is 6 minus square root of 6. Again, it cannot be simplified, so therefore, that's the end of it. The next one, though, because it's going to be binomial times binomial, you're going to have to FOIL it. So we have, on this one, square root of 3 plus 3 times square root of 5 plus 2. Okay, so what's going to happen? Well, first of all, we're going to multiply this one times this one. They're both inside the house, so you have square root of 15. And then square root of this one times this one is going to give you plus 2 square root of 3. And then this one times this one plus 3 square root of 5. And then 3 times 2 is plus 6. Now notice, none of those are like terms, and it cannot be simplified any more than that. So how about bigger numbers? About something like the square root of 98 times the square root of 2. You simply multiply what's inside, and this is 196. Well, 196 is a perfect square. This would be 49 times 4. 49 is a perfect square of 7. 4 is a perfect square of 2, so this is 14. So therefore, the square root of 196 is equal to 14. It just simplifies all the way down. Kind of nice. Okay. Another one of these rules to remember. Remember, multiplying square root of a times square root of b is square root of a over b. The same thing is true with division. We've done it before, but let's look at it again. So, square root of a over b is equal to the square root of a divided by the square root of b. So let's look. Square root 64 over 81 is equal to the square root of 64 over the square root of 81. Square root of 64 is 8. Square root of 81 is 9. Do not do these on a calculator, guys. We don't want you to end up with some kind of decimal. And if you don't put them in right, you're going to get the wrong answer. Go ahead and work it out. Do the square root over the square root and actually do them and leave them as a fraction. In fact, I think it will tell you to leave them as a fraction. How about this one? The square root of 13 over 9. Again, square root of 13 over the square root of 9. Square root of 13 does not simplify, and we're looking at exact values. That's why you can't use the calculator. But the square root of 9 is 3. So this leaves me with the square root of 13 over 3, and that is the exact value. Let's look at something that has a variable in it. Square root w to the 6th power over 16. Again, square root of w to the 6th power over square root of 16. We know the square root of 16 is 4. W to the 6th power. Remember, 6 divided by 2 is 3. Or you can look at w to the 6 halves, which gives you, simplify that fraction as 3, gives you w to the 3rd power. That's all the farther you can go, because we don't have anything else. Okay, let's look at another one. We're going to look at a cubed root one. It works the same way. We have negative 64 over 343. Okay? So this means the cubed root of negative 64. And remember, with cubes we can have a negative, and a cubed root of 343. Your negative only goes with one of them, and you usually put it with the numerator. So this is equal to, well, this is negative 4 times negative 4 times negative 4. Therefore, the cubed root of negative 64 is negative 4 over, and this one is 7 times 7 times 7, so therefore 7. Remember, you need 3 of a kind when you have a cubed root. So we can write it negative 4 over 7, or you could write it as negative of 4 over 7. It doesn't matter which way you write it. Okay, now we're going to look at binomial multiplications with this, and look what happens to them. Because we're going to have to use this with division. What happens here? 2 times 2 is 4. 2 times positive square root of 5 is plus 2 square root of 5. Negative square root of 5 times 2 is minus 2 square root of 5. And then negative square root of 5 times positive square root of 5 is minus 5, because that would be 25. Well, let's go ahead and write it. Negative square root of 25. Now let's simplify. 2 square root of 5 minus 2 square root of 5 gives you 0. You're left with 4 minus the square root of 25, which is 5. 4 minus 5 is equal to 1. So what happened here? Because these are like the sum and difference, remember from that when we had a difference of squares? Well, that's what this is. This is a difference of squares, and we end up with only a number because our square roots in the middle cancel each other out, which is important because we cannot have a square root in the denominator when we go to do our division with these things. So we're going to have to eliminate it by using this trick. So let's look at another one. 3 plus square root of 7 times 3 minus square root of 7. And notice the same thing happens. 3 times 3 is 9. 3 times negative square root of 7 is minus 3 square root of 7. Square root of 7 times 3 is plus 3 square root of 7. And then square root of 7 times negative square root of 7 is minus the square root of 49. Notice, negative 3 square root of 7 plus 3 square root of 7 eliminates those two middle terms, and you're left with 9 minus square root of 49 is 7. 9 minus 7 is 2. So you end up with a basic number. When you have a minus b times a plus b, these are called conjugates of each other. And we're going to have conjugates with radicals, and we'll also do conjugates with imaginary complex numbers, which we're coming to later. Okay? Since this is used to eliminate the square roots in the denominators, we're going to use that now with our division of radicals. Okay, we'll start another one.